Hola, students. Today we are going to talk about weather fronts. Yesterday we talked about air masses, and I think the next natural step is going to be talking about weather fronts. And then we'll move on. On Thursday, I will lecture on air pressure and how pressure systems bring specific types of weather. We see a lot of, when you watch the news and watch the Weather Channel, you see a lot of H's and L's with circles around them. Those are large pressure systems that are associated with air masses and fronts. But I'm going to try to do this in order to make the most sense of it. I am referring to a chapter in an iBook, a weather iBook that we aren't going to go through this year. But I just skipped ahead to this chapter on weather fronts just because it's a little bit easier to understand if I can show you some graphics here. Weather fronts are called weather fronts because of World War One. In a military usage, a front is where two opposing forces meet. This bayonet charge of French soldiers is opposing the Germans along the Western Front during the World War One. How does a weather front resemble this? Well, we said yesterday that you've got two unlike air masses that come into contact, and if they have different enough characteristics, differences in temperature and humidity, they will move in relation to each other, right? And whichever one is stronger is the one that the front is named after. So I've got these really high-tech little demonstration, this really high-tech demonstration here. I've got cold air and warm air, okay? So let's just say my head is you in Little Falls, okay? And you're hanging out in Little Falls and maybe a cold air mass. And when I say air mass, I mean it's a volume of air that can be like 1,000 kilometers across. These are very, very large sections of air. Okay, so we get a lot of air masses that come down from Canada, especially in the winter. Okay, so let's just say this cold air mass is coming and it's going to run into the warm air mass that is currently sitting in Little Falls, okay? Whichever one is bigger and whichever one is moving the fastest is the one that's going to win, okay? So let's say it's the cold one. Let's say the cold one is coming in and it's going to come into contact and it's going to overtake the warm air. What will the warm air do in relation to the cold air? Think about that. What does warm air do in relation to cold air? It will rise because it is less dense, right? Well, when a cold air mass comes barreling into a warm air mass, it creates kind of a wedge and it forces this warm air up into the high end of the atmosphere really, really quickly and kind of violently. And we get all of this warm air that condenses into clouds and forms these really big thunderheads, which we know as cumulonimbus clouds. And we get thunderstorms or a blizzard or some type of weather that is not like days and days and days of rain. It's like a big storm that comes through and it moves past and then it clears up. Okay? That's a cold front. That's what happens with a cold front. When cold air comes barreling into warm air, it forces it up into the atmosphere and takes over. And this warm air will condense and form clouds and rain. Okay? When the opposite happens, let's say you're sitting in a air mass of cold air and warm air comes in, warm air will naturally glide up over the cold air. Okay? And so what happens there is it's not like a quick, violent storm. That's where you get all of this warm air gradually moving up and clouds will start to form way ahead of the front and this warm air will gradually condense and clouds will form and it will precipitate usually over a longer period of time. Okay. Two air masses meet at a front. At a front, the two air masses have different densities and do not easily mix, kind of like oil and water. One air mass is lifted above the other, creating a low pressure zone. Okay, we're going to talk more about pressure on Thursday. Okay, so Don't let that confuse you too much. If the lifted air is moist, which warm air holds moisture, then there will be condensation and precipitation. Winds are common along at a front because the air is moving, right? Wind is movement of air. And when two air masses meet that have different temperatures, they move. Warm air will rise, and that creates wind. So usually right at the front edge of a front, like right where the two air masses meet, right at that boundary, that's going to be where the big winds happen during a storm. That's why sometimes in the summertime, if you know a thunderstorm is coming, you can feel that front moving in. You can feel all of a sudden, oh my gosh, the temperature just changed. It got cold, and boom, we get a thunderstorm for like a half an hour, and then it moves out of the way. There's 4 different types of fronts. We've got a cold front, a warm front, and those are the 2 that we're really going to concentrate on today. There's a stationary front that looks like this on a weather map. And then there's also something called an occluded front. I think I've got a picture of that. Yeah, here's an occluded front. Okay, so let's talk about cold fronts first. Okay, so on a weather map, they look just like this. They look like these little spiky things. And the spiky things are always pointed in the direction that the cold air is moving. Okay, so in this case, picture yourself standing right here and a cold air blast is coming at you. It's going to move in. You see these pointy things that are pointing in that direction. It's moving this way, and it's going to force all of the warm air that's over you up into the sky. It's going to rapidly condense and fall as rain. That's why cold fronts are associated with short-lived and kind of violent weather. Okay, you can see a squall line, that sometimes forms right along this leading edge of a cold front. Can actually see it coming in. A warm front, on the other hand, okay, so let's say you're standing right here in a bunch of cold air and warm air is approaching. Warm fronts are signified on weather maps as these little semicircles, and they're also pointed in the direction that the front is moving. Okay, so the front here is moving from left to right or from west to east. It's moving this way, and it will gradually, just because of its density difference, right? It'll gradually climb up above the cold air, and that will develop clouds over time and rain over a longer period of time. Okay, so warm fronts are associated with longer periods of rain. Cold fronts are associated with quick and violent storms. Not necessarily violent, but like those storms that come through and thunderstorms don't last for days, right? We can have days of rain, but a thunderstorm only lasts for, maybe a half an hour. Weather fronts are always named after the air mass that is taking over. Okay, so if you've got cold air right here and a warm front is coming, you are replacing this cold air with warm air. And the opposite is true with the cold front. A cold front, you're hanging out here in warm air, a cold front comes, and after the cold front passes, you're going to be left with cold air, right? The other kind, I'm not going to talk too much about an occluded front today, but the other kind is a stationary front, and it looks like it's just a combination of those symbols. And that is when, here's my little demo things again. I made these all by myself. Isn't that nice? Okay, so you've got cold air and warm air, and they're coming together, but neither of them have more speed or volume than the other. They're pretty equal. And so they'll come into contact, and sometimes they'll just sit. One is not going to push the other one out of the way. And so a stationary front is named that because it's just sitting right over you. And what'll happen is icky weather for days. Rainy, 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 rainy. Fronts are always associated with precipitation of some sort. Okay, so just because I think there's a misconception that a warm front is going to bring warm, sunny weather. That's not true. It's a air mass that is taking over another one. And whenever there's a boundary, there's going to be precipitation. All right. So we'll talk a little bit more about that, especially when we talk about air pressure systems. I just wanted to give you a little bit of an introduction to this. And your assignment for today is you're going to go to the Google Doc called Weather Fronts. There's a video right here, and there's just 5 questions that go along with it, okay? Tomorrow, Wednesday, you will also get another little video, just a review video to watch, and there won't be an assignment associated with it. It's just it'll be a little, maybe 6-7 minute video for you to watch. And then on Thursday, I'll come back and I will be lecturing on pressure systems. Okie dokie. I hope you're enjoying this cool weather. It's going to change. Summer's coming. I think we're going to be in the 70s later this week. That'll be nice. All right, I will talk to you soon.